So let us talk about complete block design 2 power k design. Okay. This is a randomized complete design RCBD kind of thing in a 2 power k framework. Okay. Instead of one factor, we are talking about RCBD in a 2 power k design. So there are n blocks. Within each block, all treatment level combinations are conducted. This is where things become crazy. You see what I mean? Now if I have to block a particular factor, for each block I have to do the 2 power k. You understand the issue, right? For each block all treatment combinations are conducted. So you have to do treatment combinations within each block. Okay. Run order in each block must be randomized. Okay. How, which factor is blocked within each, in each block you have to randomize the treatments. Okay. And this is just follows a generalized block factorial design like RCBD, but now you have to do it for the treatment combinations for each block separately. Okay. So that is where, and then you have 2 power 2 or 2 power k. When k is large, obviously you cannot afford to conduct all treatments within the each block. What is the, why is the reason? For each block you have to do treatments at multiple levels. When k becomes large, obviously you cannot do it. You understand the problem? So every block, so let me show you a simple example and then let us get on. Okay. Let us say this is a 2 power 2 design. Let us forget this for now. 2 power 2 design, there are 2 levels, 4 experiments. Okay. So suppose there are 2 factors each with 2 levels and 2 blocks B1, B2 each containing 2 runs. Okay. So there are 2 blocks, B1 and B2 is the blocks I want to apply. Okay. This could be batches, this could be operators, this could be raw material changes, whatever. Okay. This is something I do not want to, I do not want this B1 and B2 to influence my outcome. It should not be a part of an error, it should be handled separately. Remember, if I do not do blocking, my sum squared error goes higher. Okay. So I want to keep this separately. So I have 2 blocks here, B1, B2, and I have these 4 experiments. So what is the scheme I can come up with for blocking? What kind of schemes? I have written some schemes here. Does it make sense? Let us go through one by one. This is my blocking scheme 1. What is the blocking scheme 1? How is it applied? What is kept constant? What is kept variable? You saw the point, you saw you are seeing the table, right? I am talking about column 1 in blocking scheme. Huh? What is being kept or what is being? So B1 is when what? B1 is when B is negative. B2 is when B is positive, right? And what about scheme 2? B1 is when A is negative and B2 is when A is positive. And then what about third one? B1 is applied for both when A is positive and negative, and B2 is applied when A is positive and B is positive and negative, right? You see the table, are you able to see the 3 kinds of blocking scheme? See, please pay attention. This is where ideally this is the stepping stone of for doing experiment, because you will do, when you do experiments, these are the complications you will get. You will not get a neat clean RCBD or ANOVA or whatever. Okay. This is where ideally when you do start performing experiments. So you want to do 2 blocks, simple 2 blocks in a 2 power 2 experiment. There are at least 3 kinds of schemes here. 1, B when A is constant, B1 when A is constant, B1 when B is constant, or combinations. You see here B1 is when B is negative and B is, so B1 is pertaining to B negative, B2 is pertaining to B is positive, and in the second column if you take about B1 is pertaining to A negative and B2 is pertaining to A is positive, and the third column is neither one of them. B1 is B1 contains when both A and B are A is positive and negative, B2 is also applicable when B is positive and negative. So there are at least 3 different schemes in just a 2 per 2, and does this capture every, so have we done it properly, have we done blocking, complete blocking, have we done complete blocking? Remember I told you there are n blocks, within each blocks all treatment levels are conducted. Did we obey that? Did we obey this in this table? Within each block all treatment levels are conducted. Did we obey this? Yes or no? You understand my question? What is the first statement we had? There are n blocks and within each block all treatment levels are conducted. So block B1, have we conducted all? No, right? Let us say blocking scheme 1, within each block all treatment levels have to be conducted. Did we do that? Look at this, B1 is the block 1, all treatment combinations are conducted? Obviously no. Why? I do not even have A as positive at all. You understand? So this is typically the case like this. I will show you a case. Suppose there are 2 batches of raw materials. So when you have 2 batches are different, obviously 2 batches are different and each batch can be only used for 8 runs. Each batch can be only used for 8 runs. It is known these 2 batches are very different. Blocking should be deployed to eliminate this variability. Okay. In this case, like let us say take this case. This is my original. So 2 power 4, 16 experiments. Okay. But I have 2 batches of raw materials. That is not the problem. The problem is each batch can be used only for only 8 experiments. Ideally what do you want to do? You want to do 16 experiments with batch 1, 16 experiments with batch 2. That way you have blocked, you understand, all 16 combinations with batch 1, all 16 combinations with batch 2. Remember, go back to your basics RCBD, that is why the fundamentals become important. When you talk about RCBD, complete block design, for each block you do all the experiments, all combinations. Same here, if you want to understand the effect of, you want to discount the effect of batches, meaning disregard, what you should do, you have to conduct all sets of experiments with batch A and all sets of experiments with batch B as well. Then it does not matter treatment, if you look at the overall treatment effect, then you will know it is not influenced by batches because you have kept the batch constant. For all 16 experiments you have kept the batch constant, for other thing all 16 experiments you have kept the batch constant. Now what does this problem state? Each batch can have only 8 experiments. So total how many I can do experiments then? Only 16 experiments. How many I would ideally need for a complete design? How many I would need for a complete block design? 32 experiments, right? 16 with batch A, 16 with batch B. Now what do I have? I can only do 8 with batch A and 8 with batch B, right? This will be the practical challenge you will encounter. This is the practical challenge when you do experiments. You will not be able to block a factor completely because you will not be able to replicate or reproduce exactly due to availability of resources or whatever reasons. Does it make sense? It makes sense. Ideal case is what? I would want to do it at all combinations. When I do it at all combinations, there is no problem at all. It is exactly like your RCBD. I do not even want to look at it, it is exactly like your RCBD. That is why I said when K analysis follows general block factorial design, if you have done the experiments properly, but in most often you will not be able to do the experiments properly, meaning you are for whatever reasons you will not be able to replicate exactly for each block. Okay. So that is when we, so I gave you a simple example. Okay. Even in this case ideally 32 experiments would be required, you are doing only 6. Here how many experiments would be required? 2 blocks, 4 experiments, how many would be required ideally? 8 experiments. What am I doing now? How many experiments I have done? Only 4 experiments. Only 4 experiments. In 4 experiments I am doing blocking. Ideally what should I have done? I should have done it for 8 experiments, right? Each one, and this is 2 blocks. So is it 8 or more? This is 2 blocks, right? Not just 1 block. This is 2 block. In that case, in the previous example there is only one factor, which is the what? Batch is one factor, one block. Here how many blocks I have? 2 blocking variables. This is not like your your RCBD. This is with 2 factors. It is like a square. So how many experiments you have to do? For B1 you will do 8, B2 you will do 8, assuming B1 and B2 does not have interaction. So you need to do ideally 16 experiments here.
What does blocking scheme mean?
With only 4 experiments what do you do? I cannot afford to do 16 experiments now, right? Ideally what should I do? I should have done kept B2 away, B2 fixed. Okay. So in the earlier case what you will do? B1 at levels you will fix. Similarly you will have to do B1 at levels you have to fix, do it B2 at, do it separately, etc. Okay. So in here it is not possible, I do not have that much experiments. So how am I going to block? But the blocking will be only a partial block, it cannot be full, because ideally even if you take one factor B, let us call B, and B1 and B2 at 2 levels, even then you will need how many experiments? 8 experiments. How many we have? 4, right. So I have only 4 experiments, but I still would like to do blocking. That is the question we are asking. I do not have full set of experiments, I have only partial experiments because of various reasons, but I have to block invariably because I know the raw materials are different or the conditions are different. So there is no point without doing blocking. Okay. So that is the question we are asking.
So are we finding the appropriate or significant blocking scheme in order to?
Yes, we are heading there. We are heading there. What is the best blocking scheme? See, remember in this case we had 3 blocking schemes. One, A constant. First one is B constant. B1 is at one level, B2 is at another level of B. And second column if you look, B1 is at one level of A, B2 is at another level of A. And third one is both are combinations. B1 and B2 at 2 different levels of A, B1 and B2 at 2 different levels of B. These are the 3 schemes. Now can you compute the effect of block? How do you compute the effect of block for scheme 1? How do you compute the effect of block for scheme 1? When B is positive and B is negative. I said B itself divided into B2 and B1. So when it is at B2 minus B1. What is B2 minus B1? In the first column, B2 minus B1 is what? Minus, this is what I have. B2 minus is what? What is B1? B1 is these 2, okay, and B2 is sorry, B1 is what is this? Yeah, B1 is these 2 and B2 is these 2. Does this make sense? This is effect of B1, this is effect of block when block is at B2 minus block is at B1 value. This is my block effect B. Now can you compute the effect of B as well in this scheme? Can you keep this scheme? In this case, what is the effect of B? What is the effect of B when B high minus B low? If you compute, what will happen? So you can compute effect of block that we did. What is the effect of B in this 2 power 3 2 power 2 design? B high minus B low. What will happen when you write it out? B high minus B low, it will be the same as the block equation. You see the point? In the 2 power 2, just write the B equation, effect of B. Effect of B is what? B high minus B low, you can write that, okay. That is the main effect of B, and use blocking scheme 1 and write the block equation. Use blocking scheme 1 and write the block equation, B2 minus B1. Now look at both the equations, block effect and main effect, they are both same. This is called confounding. This is called confounding. So what does it mean? My main effect A, B and my block effect are confounded. I do not know which is what. You understand? Whether it is due to main effect, this outcome, whether it is due to main effect or whether it is due to block effect, it is not known. This is what is called confounding. So the effect of block and the effect of main effect of B is confounded, because both are having the same impact. Why is this confounding happening? Because you are doing what? Lesser number of experiments. So when you do lesser experiments, you will obviously have what is called confounding. Does it make sense now where we are heading to? So this is where this is what is confounding is. When you do lesser number of experiments, you are going to sacrifice something, and trust me, and practice, you will always have or most often have confounding, because there are too many factors, especially in biomedical, there are too many factors and you cannot cover all of them, and therefore confounding is invariable. Understood? So far we have never touched upon confounding, we have clean one way, two way, all this RCBD, everything nice. That is why it is called complete block design, randomized complete. Now it is not complete block design. Why? Blocking and main effect are equal, it is confounded obviously, because blocking in scheme 2 what happens? B2 and B1 are at different levels of A. In scheme 1, B2 and B1 are at different levels of B. So if I write it for scheme 2, my main effect A and block effect will be confounded, right. So this is what is confounding. This is with even single block at 2 levels, B1 and B2.
So what is exactly confounding?
You will not be able to distinguish whether this variation is due to blocking or variation in B. See, you see this equations, variation in B would have given this output if you compute with the data, and similarly variation in block could have also lead to the same answer. Now tell me, is this net output, is the output due to variation in A, B, or is it due to variation in blocking? No answer, okay, we will not be able to answer this, right. That is the challenge, okay. So if you observe only data sets with a pair, let us say Sachin and Sehwag going and winning the match, always you see as a pair. Now how do you distinguish, how do you separate them if you have not conducted enough experiments for separation? How does Sachin perform and Sehwag does not open, or vice versa? If you do not have data, you will not be able to say anything. Same here, you do not have enough data to say. Remember, these are very fundamental questions in data science. Many a times we live with what is given. I mean the algorithm or the results is as good as your data, garbage in, garbage out, right. Without naming, I had a thesis where somebody said me investing is PV, solar panel, PV is solar panels, right, PV installations, investing in this PV installations, upcoming PV installation is profitable than investing in stock markets. Then everybody would have installed, right, PV panel in your home, I would have installed big time. Data is garbage, right. So, the way you collect and then the way you can separate things, confound, that is what importance is. So, this data, so whenever you collect data and whenever you have data, the data sanity check, you have to be very clear what effects are confounded, what can you say from the data, that has to be first kept in mind. Okay. So, here you will not be able to say anything about B if you use scheme 1, you will not be say anything about A if you do scheme 2. What about third scheme? You will not be able to say anything about interaction when you do scheme 3. That is when A is both B1 and B2 are two different levels of A and B. So, obviously you should have guessed interaction is AB positive positive minus AB negative negative. So, you would have seen that interaction is sacrificed. So, you have to sacrifice either one of them. If you want to block with minimal number of experiments, what is it you have to confound? You have to sacrifice or confound either main effect or interaction effect. That is the question. So, what is the optimal strategy? What do you think is optimal strategy? What is the optimal strategy for choosing which one to lose? So, simply means confounding makes the effect inestimable, that is all, you cannot estimate that effect at all, confounding means. So, scheme 1 A effect cannot be estimated, scheme 2 B effect cannot be estimated exactly, scheme 3 AB effect cannot be estimated exactly. Now, my question is which scheme is the best or cause the least damage? Anyway, damage has to happen, meaning your experiment results cannot be without confounding, but what is better? That is what we are going to ask. Does that make sense? Everybody clear about confounding, right? This is what will happen. Okay. Now, I can ask a logical question, 16 experiments have to be performed, right. In here 4 plus 4, 8 experiments have to be performed. Which 8 to perform? Which, I mean, sorry, total 8 has to be performed here. You decide to perform only 4. Which 4 experiments to perform? Inverse question. Here somebody gave you these are the experiments I performed, and you said when I do this I have to sacrifice either A, B or AB. Now the question is which one to sacrifice? You go back and ask even before, see I have to perform 8 experiments or 16 experiments, I can only do 8, which 8 should I do, so that my sacrifice is minimal? You understand? These are the questions which we should be answering. Okay. Slightly complicated, but in reality that is what it is. Nobody wants to do hundreds. If I ask you to do 1000 experiments and come back report one small thing, what will you do? You will say 10. I will ask start from 1000, you will start from 10, right, that is the way usual. So, what is the best to choose? Okay. So, now I can go to the same question, do it in 2 power 3 design. Okay. So, 2 power 3 design, again I will have 16 experiments to be done. Okay. So, now this goes on and on. So, what is the best way to define what is the optimal, give me a logical sense, what is the optimal sacrifice one should make? Confounding effect is known, you want to confound A, confound B or confound AB. So, let us, that is why I have given you 3 factorial experiment. Let us take a slide, call and say I am doing 3 factorial experiments. Now, what is the highest level of interaction? What is the highest level of interaction in a 3 factorial? 3 terms A, B, C, is that going to have a significant effect? Is that going to have a significant effect?
Maybe we can get the glimpse of it with AC.
So the way to think about is sacrifice the highest order interaction or keep the highest order interaction to be a confounding factor. Okay. I will not go and get into the mathematical details here. If I get into the mathematical details, it will be quite complicated. So let us keep it simple. The common sense idea is what? Highest order interaction is usually will not be that much, and that highest order interaction can be known from the other interaction terms, and of course the main effects are important. See, you have chosen a variable A because it is going to have impact, otherwise you would not have even in the first place chosen, right. So sacrificing main effect is not a great idea, and interaction becomes useful only at least one of the main effect is significant. If both A and B are insignificant, AB will have no meaning, right. In AB interaction at least one has to be significant. So doing away with A or B, the main effects is not a great idea. Sacrificing the highest order interaction is good because the lower order interactions will get me an idea about the higher order interactions. Okay. See, you are sacrificing, you will not get an answer, clear answer, but what is the best way to do it is what I am saying. I can do away with ABC interaction. Why? If I know AB, BC, CA, some combinations of them which is important, then I can do away with ABC kind of. So usually what is done is your highest order interaction, you call it as define a relation B block which is nothing but ABC multiply. Okay. So this is what is this experiment? Remember I had 2 power 4 experiments to be done, 2 power 4 experiments. Due to availability, what am I going to do? Only 2 power 3, 8 experiments, because batches come for only, each batch is only 8 experiments. The raw material can be used only for conducting only 8 experiments. So I can overall conduct only 8 experiments. Remember that was the question with which we started, right? I mean this case. Okay. So this is the 2 power, sorry, where is this factorial? I had this batch question. So this is my 2 power 4 16 experiments. There are 2 batches of raw materials, so only each batch can be used only for 8 runs. Okay. So 2 batches are different. How to select 8 treatments for each block? This is a question which I want to answer. How to select 8 treatments for each block? That tells me, that is what is the optimal block, right? What is the optimal block, so that I can choose 8 treatments for each block. Remember, for each block I can only choose 8 treatments, I cannot choose 16. Ideally I would want to choose 16. Okay. So totally how many experiments I am sacrificing? How many experiments I am leaving out? Instead of 32 I am doing only 16 experiments. Obviously confounding will be there. So now the question is how to conduct so that minimal confounding, that is all, that is the question, minimal damage. So to that end, what did we decide? We said, look, I do not want to sacrifice main effects, that becomes useless because interactions become significant only if the main effects are significant. So main effects have to be known, and the highest order interaction can be known from an idea that can be got from intermediate interactions. So it is better to think about sacrificing the highest order kind of interactions. Okay. So we define a relationship B equals to ABC, which is the highest order, right. Now can anyone tell me how did I choose block 1? How did I choose block 1? See, multiply ABC, all the contrast terms multiply, this is negative 1, all the contrast terms multiply positives. Okay. this is positives, sorry, these are all negative contrast, 4 negative contrast, 4 positive contrast. You see here ABC equals to B, that is a new relationship I have defined, that is the highest order interaction. So ABC equals to B. The contrast for ABC is what? Is based on the multiplication term. Remember, so, okay. So this is so this term is I have 1 1 1, I have negative, and I am just multiplying all the contrast to get this ABC contrast. I am not putting a separate contrast for ABC. I have sacrificed ABC. Basically, I have given up ABC and said the coefficients of ABC will come from multiplication of what is there in ABC. Multiply this 3 contrast, you will get the contrast for ABC. Now block 1 is nothing but all A's are ABC is negative. Block 2 is what? All ABC is contrast is positive. This is one way to define a contrast, I mean to do a confounded blocking. Basically you do block experiments but having confounded. So you have A, so let us go by this, you have this A experiment, B, C, and then you have AB, AC, BC. So how did you get the contrast for AB, BC, CA? Just take A, BC, multiply them, you get the contrast for ABC, AB, B, AC, BC, and then similarly you do for ABC. Okay. So this is like what kind of experiment, if you want to call it, you have 2 power 3 experiment. Which one? Block third term minus plus plus. Block 2 third term is what? Yeah, 2 minus, yes, this is what it is, 2 minus should be there. Yeah, this is a repetition, this and this are repetition. So how did we come up with this table? Any idea? I gave you this table, but how do you come up with this table? Suppose you want to do only 8 experiments instead of doing 16 for each block, you want to do only 8 experiments. How do you do? For 8 experiments, how many factors, what kind of factorial design you can do? 3 factorial. You cannot do 4 factorial. You can only do 3 factorial design. Originally how many factors are there? Originally I have D, which is also 4 factors. What did I do now? I did what? Only 3 factors. I did only 3 factors, A, B, C. I did so this part, if you look at, what is this part? Is 2 power 3 design. This is your 2 power 3 design. Are you able to look at this? This is actually your 2 power 3 design. Instead of doing a 2 power 4, I did a 2 power 3 design first. I did not involve D at all, I did not involve one factor at all, because I cannot do 2 power 4. So what did I do? I involved only 2 power 3, I did a complete 2 power 3 experiment. Okay, that is what I did. And what are the interaction terms? AB, BC, CA and ABC. I can complete the AB, BC, CA terms using this. Okay. So that is what I have did. So by defining relation B equals to ABC, I have AB, BC, CA as well as ABC terms. Now what is the block I have defined? A block I have defined to be ABC positive, ABC negative. D I have not even bothered so far. D I have not even bothered so far. Okay. Now, so what will happen to D? Any idea? What will happen to D? This is one scheme. What will happen to D? You want to do, I cannot do experiments, that is the whole idea. I cannot do experiments, so what will happen? You cannot estimate main effect of D. In this case, you cannot affect the main effect of D. Okay. the D effect will be confounded with what? ABC basically, okay, interactions will confound. So the other way to do about is the following, you keep all the main effects constant A, B, C, D, okay, you have done all, this is what it is, right, you have done A, B, C, D, keep all of them, okay, and then define a factor B equals to A, B, C, D, and then define two kinds of blocks, B positive and B negative. This will sacrifice interactions, this will sacrifice interactions, you will get the effect of D, you will sacrifice the interactions, okay. Typically this is optimal, you usually sacrifice the higher order terms, not the main effects, make sense, okay. So what are we defining? You are defining the block to be the highest order interactions, and then you have conduct experiments such that the block is positive and the block is negative. If B equals to A, B, C, D, if you define 4 factors and B equals to A, B, C, D, block 1 is block, how do you define the blocks? B equals to A, B, C, D when A positive, B equals to A, B, C, D negative. So the 16 experiments can be split into 2 8s, instead of doing 32, your 16 experiments can be split into 2 8s, first 8 will be B equal to A, B, C, D positive, second B equals to A, B, C, D negative. You understand, the 16 experiments itself is split into 8 plus 8, first 8 experiments this final interaction A, B, C, D term is positive and next 8 the A, B, C, D term is negative. That is how you split the 16 experiments into 2 8s. Ideally you should have had 32, but now you only have 16, and with 16 I need to do blocks, so you divide it into 8 and 8, clear. If you want to do ideally you should have done 16 experiments with block 1, 16 experiments with block 2, that would have been costly. So now you only have 16 and you have to divide it into 2 blocks, so I divided into 8 and 8, make sense, clear. And the key to is to do away with the higher order, define a term B equals to A, B, C, D and then multiply it and then split A, B, C, D positive, A, B, C, D negative. This will involve so many, is this, will there be only one interaction term or will there be only one confounding or many confounding? Will there be one confounding or many confounding? Will there be only one confounding effect or many confounding effect? Will only A, B, C, D become confounded or will there be something else will become confounded? There will be multiple confounding effects, because you have done lesser number of experiments, there will be multiple confounding experiments. So you have to check what are all confounded, but this is the optimal way. I will not get into the math, trust me, this is the optimal way of confounding, doing the last higher order interaction term as the multiplication and keep that as positive block and negative block. That is the easiest and optimal way to do a blocking, okay. There are several ways to come up with blocking, but this is one of the easiest ways, I mean this is one of the optimal ways, because you do not sacrifice, you will go, if you do this equations analysis you will know that the main effects are not sacrificed, okay, otherwise your main effects will get sacrificed. Here in this case no, in this case I am not doing anything sacrificed, that is on the previous case, this here I am not doing anything. All interactions also will be there, it will be A, B, B, C, I did not put it, all interactions will be there, all of them will be, it is 2 power 4 right. Interaction effects you can write from this main effect only na. Why should I define separately? Last interaction is what? Main effect, you know the 2 power 2 design how to define interaction, so you can define all the interaction, but there will be confounding. The final interaction A, B, C, D will be confounded, A, C, B, C some of them will also be confounded, but you will not sacrifice the main effects, okay. So this is one way of doing, optimal way of doing confounded experiments, keep that in mind. So everybody understand the simple logic is confounding is invariable, okay, and you will not be able to do so many experiments, so you will have to sacrifice something. You want to ask a question, what to sacrifice? Confounding means the effect of a variable cannot be separated from the effect of another factor, effect of one factor cannot be separated from the effect of another factor. In general it could be block, so it may be happening that your effect of A cannot be separated from the effect of AB, possible. If you do a proper improper blocking, this is also possible, effect of A and AB is not separable, okay, that kind of answer may also come out. So what is confounding? effect of two factors are not separable, and this will invariably happen when you do lesser number of experiments, and for all practical reasons you will not be able to do all sorts of experiments and screening experiments. So confounding is invariable. So what is the how to perform now optimal confounding or a decent way of to do confounding? The logic is higher order interactions. So the simple logic is main effects are important and there are not many main effects compared to interactions. Interactions are larger, interactions are always going to be larger. When k increases, interactions are going to be larger compared to the main effects. So there are only lesser number of main effects, rule 1, and rule 2, not all interactions are important and usually higher order interactions are negligible, and you can get an idea with it by using the local second and third order lower order interactions. So that is rule 2. Using these ideas we come up with a blocking scheme where we say block is define a block based on the multiplication impact or ABC or ABCD impact of the individual factors. So two blocks where we say ABCD or A to K positive and A to K negative, that is the way we do the blocks. And again, even if you do the blocking, the confounding in this group will depend upon the number of experiments you have done. Suppose you have done only 4 experiments, you will obviously have more confounding effects. Even to distinguish ABCD you need 16 without blocks, and now suppose you have done only 4 experiments, it is worse, your confounding will be significantly higher. Okay. So number of experiments determines your confounding. Make sense everybody? I am just giving you an overview, I am not getting into the math details etc. This is slightly at an advanced level where you start doing experiments. Okay. So that is what I would say. We will stop here, I will not get into the SAS output etc. Okay. And you know we can even talk about 2 power p blocks, but that will be quite last slide we will talk about it. Okay. But I think that is what I wanted to cover with regard to blocks and confounding.